From the previous video, I was able to discuss the 4 basic formulas in integration. In this video, I will be discussing the next 3 formulas in integration which yield to exponential and logarithmic functions. So here, given u as a differentiable function of x and a is a constant, then the following formulas can be used. Integral formula number 5. The integral of du over u is equal to the natural log of u plus c, the constant of integration. Integration formula number 6 states that the integral of e to the power u du is equal to e to the power u plus c. And the 7th integration formula is the integral of a to the power u du is equal to a to the power of u divided by the natural log of a plus c. So at this point, I will be giving examples that will illustrate the use of these 3 basic formulas in integral calculus. So example number 1. What is the integral of x squared dx divided by x cubed plus 1? You notice that the integrand is a rational function because in the numerator you see there x squared, and in the denominator we have x cubed plus 1. Now remember that in integral calculus there is no quotient rule. There is no straightforward formula for quotients. So what will you do? We will rewrite this integrand such that it will be integrable. Now, if you are an experienced person in integral calculus, you can really identify that if I let the denominator as my u, say u is equal to x cubed plus 1, I realize that when I get the differential of this x cubed, the differential is 3x squared dx, which I noticed that some expression here are found in the integrand, and I realized that I have this x squared dx in my numerator, but I don't have 3 as a numerical coefficient there. So what will I do is I will divide both sides by 3. So du over 3 is equal to x squared dx. So here I know that the value of x squared dx is du over 3, and the value of my x cubed plus 1 is my u. Now by substitution, I can rewrite the original integrand like the integral of the numerator, which is x squared dx. Instead of writing x squared dx, I will write du over 3. So I will write here du over 3. And the denominator, I realize that this is my u. So instead of writing x cubed plus 1, I will write its equivalent expression, which is u. So now my integrand is in terms of u this time, but I see here a constant 3 in the denominator of du, but that is okay because I can factor it out using formula number 2 in our previous video, that this can be written as 1/3 times the integral of du over u here. Now you notice that this integral du over u is the same integral in my formula number 5. So I can apply now the formula there, that this is equal to 1/3 times the integral of du over u, which is the natural log of u, and plus the constant of integration of c. So see here. Now I need to go back to what is the value of my u. My u is just equal to x cubed plus 1. So my final answer is 1/3 times the natural log of x cubed plus 1 plus the constant of integration c. And this is our answer for our example number 1. So example number 2. Suppose we want to find what is the integral of x cubed plus x minus 3 when this is divided by x minus 1. And of course, we have here a dx as a partner of our integral symbol. So remember again that there is no quotient rule in integral calculus. So how are you going to integrate this? Now, we notice that this is an improper fraction. Why? Because you see a polynomial in the numerator there, which is on the third degree. And in the denominator, it's a linear function. So this is an improper fraction. So what will you do is you need to divide the numerator by the denominator. So how are you going to divide? You can do long division or you can do the synthetic division. Suppose we will use the synthetic division, how will you do that? So I may write here the numerical coefficient of x cubed, which is 1, and because I don't have x squared term here in this polynomial, I need to provide a coefficient holder for x squared, which is 0. Also for the x, I have 1. And for this one, a constant of negative 3. And I want to divide that one by this one, which is of the form x minus r value. So my r value there, it's 1. So if I divide, I need to bring it down. 1 times 1, it's 1, and then I add, so that's 1. 1 times 1, it's still 1, and when I add, that's 2. So 2 times 1, it's 2, and then when I add, that's negative 1. The last number is my remainder. When I divide this x cubed plus x minus 3 by x minus 1. So what is the quotient when I divide this one? The quotient is 1 degree lower because this is a cubic polynomial and the divisor is a linear. So the quotient is x squared plus x plus 2 with a remainder of negative 1. So I can rewrite the remainder as minus 1 over the divisor of x minus 1. So this is now the resulting function that we need to integrate. So the integral of x squared plus x plus 2 minus the fraction 1 over x minus 1 dx. So this time you see that we can integrate clearly this polynomial, but I have a rational here. But that's no problem because I can rewrite this like the integral of x squared plus x plus 2 dx, because I can separate this polynomial from this rational by applying formula number 3 in the previous video, that we know that the integral of a difference is equal to the difference of their individual integrals. So this is minus the integral of 1 over x minus 1 dx here. So I just separated this polynomial from this rational. So I can integrate x squared using the power rule in the previous video, and that's formula number 4. That's x cubed over 3. And the integral of x is x squared over 2. And the integral of 2 is 2x. However, I can rewrite this as the integral of dx over x minus 1, because 1 times dx is just dx, and then over x minus 1. So to continue, this is equal to x cubed over 3 plus x squared over 2 plus 2x, and I realize that this one can be transformed like my formula number 5, that when I let u to be the denominator x minus 1, I realize that when I get the differential of my u, this is dx, because the differential of x is dx. And you notice that the value of the dx is my du, and the value x minus 1 is my u. So I can substitute this expression here, that instead of writing dx, I can write equivalent expression du here. And then instead of writing x minus 1, I can write its equivalent expression, which is u there. So I can have x cubed over 3 plus x squared over 2 plus 2x, and we know that the integral of du over u in the formula, that's the natural log of my u, and then plus c. Finally, our final answer is x cubed over 3 plus x squared over 2 plus 2x minus the natural log of my u, which is x minus 1 plus the constant of integration c for all the integrals. And this is my answer for my problem number 2 here. Now let's proceed to problem number 3. What is the integral of cosine x over 2 plus 5 sine x dx? Now remember, again, there is no quotient rule for this. So if you are a beginner, you find it a little bit difficult. But you can transform this integrand such that you can format this one like one of this formula. So what will you do is just to assign some expression there to your variable u. So what could be your u? Your u is a set of expression wherein the du must be there in the integrand. Now, we realize that when we let our u be equal to 2 plus 5 sine x, I realize that the derivative of this expression is just 5 cosine x dx. Why? Because the derivative of 2 is 0, and the derivative of sine x, it's cosine x. But of course, we have here a numerical coefficient of 5. But as you can see, I don't have this 5 in my integrand here. But that's not a problem, because I can divide both sides of the expression by 5 to eliminate 5 at the right-hand side of the equation. So what will remain at the right is just cosine x dx. So by substitution, I can rewrite this one, the cosine x dx. Instead of writing cosine x dx, I can write its equivalent expression, which is du over 5 here. And the denominator, you know that that is our value of u. So instead of writing 2 plus 5 sine x, I will write its equivalent expression, which is u. So this is u. Now, there is a constant 5, but that's not a problem because I can use formula number 2 in the previous video that we can factor out a constant in integration. So this is 1/5 of the integral of du over u. There. And again, you realize that this is same with our formula number 5. Now, in our formula number 5, it says that the integral of du over u is equal to the natural log of u plus c. So I can apply that. That is equal to 1/5 times the natural log of u plus c. But of course, we need to go back to the original variable of the function, which is in terms of x. And we know that our u is just 2 plus 5 sine x. So we have here the natural log of 2 plus 5 sine x and plus the constant of integration c. So this is our answer for example number 3 here. Now, let's proceed to example number 4. What is the integral of e to the power x plus e to the power negative x over e to the power x minus e to the power negative x dx? How are you going to integrate this rational function? Again, it is something scary looking at this expression. But actually, you don't need to panic. Just relax because you realize that when you let u be equal to the denominator e to the power x minus e to the negative x, this denominator, I realize that I can get my du that is the same with the numerator, because when I get the derivative of e to the power x in our differential calculus, the derivative of e to the power x is e to the power x times the derivative of the numerator x, which is 1. Also, the derivative of e to the power negative x is just e to the power negative x times the derivative of negative x, which is negative 1 by the chain rule. And of course, because this is a differential, there is dx. And you notice that when you simplify this one, this is equal to e to the x plus e to the negative x quantity multiplied to dx. Why plus? Because the negative times negative is positive. And you notice that this one is our numerator. So instead of writing our numerator, which is e to the x plus e to the negative x dx, we will write its equivalent value, which is our du. So this is du over our denominator, which is we set as u. So this is u. So again, using formula number 5, this is equal to the natural log of u plus c. And what is our u again? Our u is just e to the x minus e to the negative x plus c. And that is our answer for our example number 4. So let's proceed to example number 5. What is the integral of secant x dx here? Now, in this integrand, which is secant x, I have not introduced to you what is the formula for the integral of secant x. So how are we going to integrate this one? We will use a clever technique. If you are an experienced person in integral calculus, you need to think in advance that when I multiply secant x by the expression of secant x plus tangent x over the same expression secant x plus tangent x, we realize that we did not alter our integrand because our integrand of secant x is just multiplied by an expression which is equal to 1. Why? Because this is an expression divided by itself. So this is just equal to 1. So this integrand is just the same as this integrand, but we just transform to another form. So when I multiply this one, I need to distribute our secant x to this binomial. So this is equal to the integral of secant squared x, because secant x times secant x is equal to secant squared x plus the secant x times tangent x here, because secant x times tangent x is secant x tangent x. But of course, there is a denominator which is secant x plus tangent x dx here. Now, this is a little bit scary because the original integrand, which is just one term, now becomes a rational function. Now, what is the purpose of multiplying this? Because my goal is to transform this one to formula number 5. Because I realized that when I let u be equal to secant x plus tangent x, and when I get the derivative of my u, the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. Of course, there is a dx here because this is a differential. Now you realize that in the numerator here, it is just the same with my du. So instead of writing that expression, I will write du because that is its equivalent expression over my denominator, which we set as our u here. And hooray, you realize that we can apply formula number 5 because the integral of du over u is just the natural log of u, and there is a constant of integration c. So our final answer here is just the natural log of u, where our u is secant x plus tangent x, and of course plus c. And this is our answer for problem number 5. So far, our first 5 examples that I presented in the previous board is just an application of our formula number 5. So here, let's see some examples that would use formula number 6 and 7. So example number 6 here. What is the integral of e to the power 5x dx? Now you see that our integrand is an exponential function. So it is impossible to convert this one like an integrand the same with the formula number 5. So this integrand is closer to formula number 6. So what if we will use 5x as our u? So when we use 5x, which is the exponent of our natural constant e, as our u, we realize that our du is just equal to 5 dx, because the derivative of 5x is 5. Now I can rewrite this integral like this is e to the power u, because instead of writing 5x, I will write its equivalent expression, which is u. And also realize that I have a dx here, but I have a 5 dx here in our representation. So I need to eliminate 5 by dividing both sides by 5. So this is du over 5, which is equal to dx. So now our dx is just equal to du over 5. So instead of writing dx, I will write its equivalent expression, which is du over 5. So here du over 5. Now you see that there is a constant of 5, but that's not a problem because I can factor out that constant 5 in the denominator as 1/5 outside by applying the formula number 2 in the previous video. So this is 1/5 times the integral of eu du. And you see, hooray, that we can apply formula number 6 at this time. And this is equal to just e to the power u plus c. So this is 1/5 of e to the power u plus the constant of integration c. And we know that our u is just 5x. So instead of writing u, we need to go back to the original expression, which is in terms of x. So this is our answer for our example number 6 here. So let's proceed to example number 7. Our example 7 is, what is the integral of e to the power sine 4x times the cosine of 4x dx. Now, this is something a little bit weird because there is a trigonometric function and there is also an exponential function. But that's not a problem, because if you can think in advance, if you can guess ahead that when you let your u be equal to sine 4x, you realize that your du is an expression that can be found in our integrand. So if you get the derivative of our u, that this is equal to cosine 4x times the derivative of 4x, which is 4, by the chain rule. And then we have here dx. And you see that this expression is not totally the same with our integrand here, with the dx, because I have a 4 as a numerical coefficient to cosine. So what will I do? I need to eliminate that 4 by dividing both sides of the equation by 4. So du over 4 is equal to cosine 4x dx. So by substitution, I can rewrite the exponent of e as u, which means that instead of writing sine 4x, I will write its equivalent expression, which is our u. So e to the power u times the cosine 4x dx, which we have here, that this is equal to du over 4. So instead of writing that, I will write du over 4. But there is a constant in the denominator of du. So I can factor it as 1/4 outside. So this is 1/4 times the integral of e to the power u du here. And we realize that we can apply formula number 6 here, that this is equal to e to the power u plus c. So e to the power u plus c. And then when we go back to our original function, which is in terms of x, our u is just equal to sine 4x. So 1/4 times e to the power sine 4x plus c is our beautiful answer for our example number 7. Now let's proceed to example number 8 here. What is the integral of 5 to the power 3 minus 2x dx? Now you see that our integrand is still an exponential function, but the base is not the natural constant e, but some constant which is here 5. So looking at these three formulas, we can apply formula number 7, that when we let a be equal to 5, so our base is 5, and our u, which is the exponent of 5, which is equal to 3 minus 2x, I realize that when I get the derivative of this 3 minus 2x is just equal to 2 dx, because the derivative of 3 is 0 and the derivative of minus 2x is just negative 2. And of course, we have here dx because we are looking for the differential. So we can rewrite this like the integral of a, because our 5, we let that one as our a. And then the numerator 3 minus 2x as our u here. So a to the power u. And we realize that I don't have negative 2 here because we have only dx here. So what will you do is to eliminate negative 2 by dividing both sides here by negative 2. So du over the negative 2 is the value of our dx. So our dx is equal to du over the negative 2. So instead of writing dx, we will write du over the negative 2. And you see that there is a constant in the denominator of du. So we'll apply formula number 2 in the previous video of integral calculus, that this can be factored as negative 1/2 times the integral of a to the power u du here. And you see that we can apply this formula number 7, that is equal to the a to the power of u over the natural log of a plus c. So going back to the values of a and u, so we have here minus 1/2 times a, which is 5, and our u, which is 3 minus 2x, divided by ln, the natural log of 5, and then plus c. Or we can rewrite this as the negative of the fraction 5, the exponent 3 minus 2x over 2 times the natural log of 5 plus the constant of integration c, because 2 times the natural log of 5 is this. So this is our answer for our example number 8. So let's proceed to example number 9. What is the integral of 3 to the exponent of secant x times secant x tangent x dx? Now, you see here that our integrand is a product of two kinds of functions. We have here trigonometric functions, and we have also here exponential function. But remember, there is no straightforward formula for product in integral calculus, but we can apply some technique, the technique of substitution in integration, that when you are clever enough to identify our u, you can see in advance that when you let your u be equal to secant x, our derivative of our secant x is just secant x tangent x dx in our differential calculus, because the derivative of secant x is this, and we see that this is part of our integrand. And when you let also 3 as our a, so by substitution, this is equal to the integral of a. So instead of writing 3, you will write a, because we represent 3 as our a, and secant x as our u. So integral of a to the power u, and instead of writing secant x tangent x dx, we will write du here. So this is du. And looking at this integrand, this is the same here in our formula number 7. And according to the formula, that is equal to a to the power u divided by the natural log of a plus c. So what is our a? Our a is 3. And our u is secant x. So 3 to the power secant x over the natural log of 3 plus c is our answer for example number 9. So let's proceed to our last example, number 10. What is the integral of e to the power ln e to the power x dx? Now looking at this integrand, it is a little bit complicated, because that's a natural constant e raised to the exponent of the natural log of e to the exponent of x. This is a little bit complicated if you don't know properties of logarithms, that e to the power ln e to the power x, this is just the same as e to the power x, because that's the property of logarithms, that e to the power ln e to the power x is just e to the power x, meaning the natural log ln and the base of the natural constant e cancels each other, and that is e to the power x dx. And that is very easy integrand, and you don't have to worry a lot, because when you let u be equal to x, you notice that the derivative of x, the differential of x, is just dx. So by substitution, that is the integral of e to the power u, because x is our u, and dx is our du. So the integral of e to the power u du, we can apply formula number 6, that is equal to e to the power u plus c. And what is our u? Our u is just x, and then plus c. So this is our answer for example number 10. And that's it. If you learned something today, please check out my channel for more videos like this, and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.